What's up, guys? Digger Ben here. Today we're going to talk about soil swell. So when you're estimating earthworks volumes, especially on bigger jobs, you're going to want to know about soil swell and how it affects your quantities. So natural ground undisturbed is called banked. So you have banked cubic meters. So for this example, we're going to use 10,000 cubic meters on an engineer's estimate that you got to move. So once you actually hit that with a machine and dig it, you're going to introduce air into the dirt. And that's going to turn it from a natural ground with no voids into a loose state. So you're going to introduce air, you're going to kind of fluff it up, and that's actually going to expand your volume. Most soils, they range between 10 and 30%. For this example, I'm going to use 20%. So you go from 10,000 banked cubic meters to 12,000 loose cubic meters. So how that affects it is that when you are figuring out your dump sites, or you're figuring out how much material you actually have to move, it's not 10,000, it's actually 12,000. So when that dirt stays in a loose state, it actually swells up a little bit. So once you hit your dump site, if you're going to place it and just leave it, it's going to stay in that kind of that loose form around 12,000 cubic meters. If you're going to compact it and add water, you're actually going to shrink it back down a little bit. So you're going to lose about 10%. So you go from 12,000 cubic meters loose in the truck, you dump it, spread it, compact it, and add water. You're going to remove those air voids, and you're going to turn it into 10,800 compacted cubic meters. So why that's important is when you're figuring out your dump site volumes, you're starting with 10,000 on the engineer's estimate. If you're going to place it and compact it, you actually need to add 800 cubic meters to that volume. It doesn't sound like a lot, but when you're getting into the millions of cubic meters moved, it's a big number. So once you place it and compact it, you're going to remove the air voids using compaction and water and squeeze that material back down close to its natural state, but you can never get it back to that 100% how it was in the ground. If you like what you see, we're going to have a couple more videos on this coming up next.